Welcome to episode 14 of the Head in the Clouds video series. I am Ken Hartman, a SANS certified instructor and content creator for the SANS Cloud Security Curriculum. Today's episode is titled, Make a Container of Cloud Tools. And this episode builds on episode 13, Docker Jumpstart. So now that we've learned some basics about Docker, let's build a useful image that we can use in future Head in the Cloud episodes. We will build a container image that has each of the command line interfaces, one for AWS, Azure, and GCP. For this episode, we will assume that you have Docker Community Engine installed on an Ubuntu 20.01 machine. Refer to episode 13 for instructions on installing Docker. A Docker image is created using a Dockerfile. So to start, add a line to a new Dockerfile to specify that our base image will be Ubuntu. Next, we need to look up the commands to install the AWS CLI. According to the Amazon documentation, the commands are as shown on screen. But let's test them in a container based on our Ubuntu image to see if we're missing any dependencies. Spin up the container in interactive mode as follows. And then paste in the first command. We see that we get an error. As suspected, curl is not installed yet. Let's install it. Okay, try the curl command again. Good. Now try the next command. It's not installed either, so install it. Now we can unzip the file that we downloaded to our container. At this point, we can try to install the AWS CLI. Oops, sudo is not installed either, so let's add it as well. And now, finally, we can run the CLI installer for AWS. To test that the CLI was properly installed, we can run AWS space -- version. All right, hence we can conclude that the full set of commands to install the AWS CLI are as shown on screen. For good housekeeping, we remove the zip file as it is no longer necessary. Also, since these commands were executed as root, we technically did not need to install the CLI using sudo. However, toward the end of the episode, we will be modifying our container so that we can use the CLI tools from a non-privileged user, and that will require that we create our image with sudo installed. Type exit to exit the interactive container. In a Dockerfile, it is considered a best practice to separate related commands with a double ampersand. A double ampersand means execute the following command only if the previous command ran successfully. By running successfully, it means it returned an exit code of 0. Okay, let's add this to our Dockerfile as a run command. Let's add a descriptive comment above it and an empty line after it. Every run instruction creates a new layer or intermediate image, and that's why related commands are grouped into a single run command. See the Docker documentation to learn more. Now let's test our Dockerfile. First by building our image. And then by running it. Now we should be able to run AWS -- version. Good. As before, type exit to terminate the container. Now, to repeat the process for the Azure CLI. From the Azure documentation, we can see that the commands that we need to use have been copied into Visual Studio Code. For the sake of consistency, let's use the short form of apt versus apt-get and add the -y switch to all the install commands to make them non-interactive. Let's append that to our Dockerfile as a run instruction, separating each of the above commands using the $&. Let's add in the comment line at the beginning for the Azure CLI and an empty line at the end. Taking a look at our latest Dockerfile, everything looks good. Okay, well, let's test this bad boy. Once the build process has finished, we can launch our container, and then we can run az -- version, and we see output. Very good. Exit the container. One more cloud service provider to go, Google Cloud Platform. The nice thing about the Google documentation is it provides you with the Docker run command. Let's use a text editor this time to modify the Docker file. And when we're done, it should look like this. It's time to test it again, first by building it, and then by running it. When we get the container's prompt, we can run gcloud -- version, and then we get our results. Test is good. It works, so exit from the container. There's one more big thing we have yet to do. The cloud command line interfaces are designed to be run as a non-privileged user. So let's make that change to our Docker file. Using our text editor, add the following lines right below the "from Ubuntu" line at the top of the file. What do these commands do? Well, first, we are adding a new user called HITC, complete with a home directory. Next, we install sudo so that the sudoers file is created as part of the install process. Lastly, we need to add a line to the bottom of the sudoers file to prevent the prompting for a password when sudo is run from the HITC user context. The user instruction tells Docker to switch to the HITC user for the following steps, while the workdir instruction changes the working directory. To learn more about these instructions, see the official documentation. When you're done, make sure the Docker file looks as shown on the screen. Great. Let's test the build. Note that it will take longer because Docker will use cached layers if it can. But since we're now installing the 3 CLIs under the HITC user context, all of the immediate containers will need to be rebuilt. We have an error. Upon inspection of the error, we can see that it is in the run command that installs the AWS CLI, and it is a permissions denied error. Since it worked before we changed the execution context to the HITC user, it is clear that we are missing some sudo commands. Change the run instruction as follows. Replace the first two occurrences of apt with sudo apt. Then when we rebuild it, it looks like it throws a second error. It's the same type of error as before, but this time in the gcloud run instruction. Change the last two lines of the Docker file to read as follows. And now it should build without an error. Awesome! And now we can run it and put it through its paces. Everything looks good. Well, there you go. We created a Docker image that has each of the command line interfaces for AWS, Azure, and GCP. Along the way, we performed some troubleshooting and configured the image to execute as a non-privileged user. At this point, you should have confidence creating your own custom Docker images. If you have thoughts or comments on today's episode, feel free to chime in on the comments for this YouTube video. If you appreciate this video and want to see more like it, be sure to give it a thumbs up. Stay tuned for another installment of Head in the Clouds as announcements of new episodes are made on the SANS Cloud Security Twitter feed. Meanwhile, be sure to check out the other great videos on the SANS Cloud Security YouTube channel. Take care.